Hello everyone, welcome to the next lecture on the multivariate normal distribution. Today I will explain you how you can understand the term independent variables. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of applied multivariate analysis and you can see the bivariate normal distribution, multivariate transformation and many more lectures are available in this playlist. You can follow my YouTube channel and subscribe it for finding the more videos and get the notification. What is the objective of this lecture? We will see if you have a multivariate normal distribution X, then under what condition you can say these variables are my independent or not. In more elaborative way, if I have a normal distribution, multivariate normal distribution X such that the mean is my here and the positive covariance matrix is given to be this, then which of the following is my independent random variable, whether x1 and x2, whether this relation or this relation. How you can identify that which random variables are my independent? The concept is very simple. I will explain you how you can check that with the help of the three different methods. Make sure before understanding the today's lecture, whenever you are talking about this third method, that is a transformation, you must watch about my last lecture on the transformation of random variable, because in order to understand this transformation method you must know how you can transform the random variable from one to the another. That is available at my YouTube channel Dr. Harish Garg. That's why I'm asking you can subscribe my YouTube channel so that you can get the notification in advance. Now recall that whenever we are talking about the one dimension random variable or the two dimension random variable, when you can say the two random variables are my independent, when the joint density function, this is my joint density function, is equal to the product of the marginal density function, then you can say the random variables are my independent. Also, we all know if x and y are independent, then the covariance between them is 0 always. But remember, converse is not true. That means whenever you are talking about the two-dimension random variable, then x and y are independent. This implies covariance between x and y are my 0, but converse is not true. So that means we have to think about under what condition this converse is also true. So that result is overcome in the multivariate normal distribution. What the result suggested you? If you have the multivariate normal distribution x and y such that they are independent if and only if covariance is my 0. So the multivariate normal distribution is the only property, the most important property of this multivariate normal distribution is this result is if and only if. However, in the two dimension random variable, this result converse is not true. So once you prove that the covariance of x and y are my 0, that means x and y are independent. So that is the brief overview about this my second method. Fine. For this method you need to understand the transformation lecture, and while I will explain in this lecture all these methods with the help of the examples here. And for this, how you can check about this, we will need some results. So for that I will explain you the first result as here. If x is my multivariate normal distribution with the dimension p plus q such that x is my x1 and x2, that is my partitions, such that mu1 is the mean of the x1, mu2 is the mean of the x2, and x1 and mu1 is of the p dimension. So therefore x2 and mu2 are, because the total is my p plus q dimension, so it is my q dimension. Then your target is to prove the necessary and the sufficient condition is covariance 0, that is if and only if. The proof is very simple. Firstly, assume that they are independent. What does it mean? That means the covariance between them, that means here what is the covariance between them is sigma 1 2. That means sigma 1 2 is 0 and sigma 2 1 is 0, because this sigma is always my symmetric matrix. So it is enough to write only as here. So what does it mean? What is this meaning? That is the covariance. So that means covariance is my 0. Converse part. The first part is very easy. Converse part, I assume covariance between x1 and x2 is my 0. What does it mean? That means sigma 1 2 is my 0 and sigma 2 1 is my 0 from here. Now what is your target is? So your required target is to prove x1 and x2 are independent. So how you can prove the independence? That means you have to prove the joint density functions of x1 and x2, that is the x is product of the marginal density function. The proof is very simple. I will explain you in a very simple manner. Firstly, I can start with the joint density function. Since x follows my multivariate normal distribution with the p plus q dimension of mu and sigma. So therefore f of x will be 1 over 2 pi of dimension of this. Now remember, what is my covariance matrix here? And sigma 1 and sigma 2 both are my 0. So therefore this value will be my sigma 1 1 0 0 sigma 2 2. Now what is the sigma inverse? Sigma inverse will be sigma 1 1 inverse 0 0 sigma 2 2 inverse. Also I need this value, determinant of this sigma. What is the determinant of this sigma? Sigma 1 1 sigma 2 2. So I can substitute this value at here, but before that I can calculate this value. What is the x is? x1, mu is my mu 1, so x1 minus, and it's a transpose, so I can return this number as here. Fine. Now you can multiply these two matrix, because this is my 2 cross 1 and this is my 2 cross 2, or this is basically a p plus q into 1 and this is p plus q into p plus q. Once you can multiply them, you will get as this matrix. Again, this is the first column, this is the second column. You can multiply them, you will get this matrix like. Now this is the variable of the x1 only, so I consider this number is my q1, this number is my q2. I can substitute this q1 and q2 here. I can substitute this value here. I can break this 2 pi p plus q as of this quantity. Now I can set, because this value I can return as q1 over 2 into q2 divided by 2. So x1, which is of my p dimension, this is of my q dimension, I can separate it as this way. This is the function of the x only, so I call this is my x1, this is my x2, which is the product of the marginal density function. Hence x and y are my independent. The second result, and this is one of the most important result. What is the result is, if x is my multivariate normal distribution, y is equal to ax, y2 is equal to bx. That means they are some transformations. Fine. Where a and b are my scalar vectors. Then find the condition that y1 and y2 are independent. Fine. Again you can see these are my multivariate normal distribution. So we need to firstly check what is the y1 and y2. This also follows the multivariate normal distribution. Fine. So I can take the transformation y is y1 y2. So therefore y is equal to transformation of x. What is the a? This is a, this is b, this is my x1 and x2. Fine. This is my c. Now because we know the transformation, what is the rank of the c? So since it is only the one row, rank is my 1, which is less than of this value p. Therefore matrix is my singular. So once the matrix is my singular, so this y will follow the multivariate normal distribution with 1, and this is my here. Now, how you can take them? As I told you, you must watch my transformation lecture. This is the way as I told you in the transformation part. Now you can find the value of the C of mu. What is the C? C is my A of B. Mu is my mu1 and mu2, where mu is the mean of the x and y, x1 and x2. This is A mu1 plus B mu2. I can find this second component, C sigma C inverse, that is basically called as the covariance matrix of y. This is called as mean of transformation 1. So I can substitute this value. C is my A comma B. Sigma is not given, so I consider this is in journal. This is my sigma 1 2, sigma 2 1, sigma 2 2. This is my A transpose, A transpose, B transpose. Now you can multiply them. Once you can multiply them, you will get this as the matrix. Now, what is the condition for the independence? That means the diagonal off diagonal entries are my 0. That means this value A sigma B transpose is 0 and this value is my 0. Fine. Now always remember, I can return this number as again this value I can return like A sigma transpose B transpose is 0, because we all know AB transpose is B transpose A transpose. Now, as sigma is my positive covariance as well as symmetric matrix. So what does it mean? That means sigma transpose is my sigma. So basically this is my same thing. That means the condition for the independence is A sigma B transpose will be 0. So if you have the two transformations, find the value of A, find the value of B, find the covariance matrix and put them as a 0. Then you can say it's independent. If A sigma B transpose is non-zero, then the variables xi's are not independent. Now I will explain you all these three methods with the help of the illustrative examples. I can solve each problem with the three different methods so that you can learn it in a very simple manner. I hope you can like my videos as it is very useful for you. You can watch till the end of this here. Now you can see I will explain you each question with the help of the three different methods. First question. Now multivariate normal distribution is given to you, mean is given to you, this is the covariance matrix is given to you. Which of the following is my independent? So let me firstly calculate x1 and x2. Fine. Now there are the three methods. Firstly I will use the covariance. What is the covariance of x1 comma x2? You can see this is the x1, this is the x2, this is the x3, this is the x1, this is the x2, this is the x3. Now can you find the value of x1 and x2? This is minus of 2, which is non-zero. Therefore if it is non-zero, then x1 and x2 are not independent. Fine. So that result is very simple for you. Similarly, if you look about the second part, whether the x2 and x3 are independent or not, can you find the covariance of x2 comma x3? What is the value of the x2 comma x3? This is my x2, this is my x3, which is 0. So once it is a 0, it means x2 and x3 are my independent. Fine. This is the second method as I explained. But if you want to learn the first method for this problem, what is the second method is? If you are using the transformation A sigma B transpose, what is my A? For example, for the first case, what is the y is? I consider y is my x1 and this is my y2. So what is my A? A is the coefficient of x1 and x2. B is the coefficient of x1 and x2. So I can substitute here. A will be my 1 0, sigma will be, so sorry, these are the three variables. So it has a three random variable. So x1, x2 and x3. So x3 is 0, x3 is my 0. So it will be, you can see 1 0 0, and it will be 1 minus 2 0, minus 2 5 0, 2 0 0, and it will be 0 1 0. Can you multiply this matrix? So you can see the first value will be minus of 2, this is 5, this is 0. If you multiply them, again you can see which is my non-zero, therefore they are my not independent. Okay, look at this third case. Now you can see this is the x1 and x2 as a one pair, but there is no one pair is given to you. There are the two methods. Firstly, I can found the covariance. So before that covariance, you can take as a partitions. I consider this is my y1 or say x1. Then I can write this value as this is my x1, x2, or instead of the x1, x2, I consider this is my x1, that is my here, and this is my x2. This complete is my x1, x2, this is my x. Now, what is the covariance of x1, comma x2? So what does it mean? x1, this is my x2, this is my covariance. Fine. So covariance is, you can say, is a 0. Therefore, they are my independent. Fine. Once they are 0, so we can see they are my independent vectors. Otherwise, you can use the second method. What is the A corresponding to the first case? Fine. It is, but there is no relationship between them, whether it is my x1 plus x2, and so you can't find the value of A from here. For example, this case. So firstly, first method I will explain you with the help of A sigma, then covariance, and then transformation. So can you write the value A? If I write this value y is ax, and this value of y2 is my bx. What is my A? Coefficient of x1, coefficient of x2, coefficient of x3. What is my B? Coefficient of x1, coefficient of x2, coefficient of x3. So A and B are my here. Therefore, A sigma B transpose. A is my 0.5, B is my this. What is the sigma? Sigma is 1 minus 2 0, minus 2 5 0, 2 0 0. B transpose 0 0 1. Now you can multiply them. What will happen is a 0.5 is a 0.5 0. Now you can multiply them. First number is a 0, second number is a 0, third number is 0. Now can you multiply them? 0 plus 0 plus 0, that means 0. Hence this is my independence. So therefore y1 and y2 are my independent. y1 is my x1 and these are my independent. This is my first method. Second method is I can apply the covariance property. Fine. So what is the property of the covariance? I can written as half covariance x1 x3 plus half covariance x2 x3. Fine. I can open the property of the covariance. Now you can substitute the value. What is the x1 x3? This is my sigma given to you. x1 x2 x3, x1 x2 and x3. What is the answer of the x1 x3? 0. So it's a half 0. x2 x3 0. So the total answer is 0. So once the covariance is 0, therefore these are my independent random variable. So you can see this is the second method which is getting a same. Third method is you can use the transformation. Fine. I can take y1 and y2 here. You can write this matrix in the form of C of x. First line 0.5, 0.5, x3 is my 0, 0, 0, 1. Fine. So this is my C. Then what is the rule for the transformation? This is my C. then you have to check whether this matrix is my singular or non-singular. How you can check about the singular and non-singular? I can find the rank of the matrix. If this is equal to the number of the column vectors, then it is my non-singular, otherwise singular. So what is the rank of this matrix? Can you find the rank of C? Rank is my 2, which is less than of the number of the column vector. So therefore C is my singular matrix. So once you got as a C is my singular matrix, therefore this Y will follow again the multivariate normal distribution with the value is my 2, and the answer is C sigma C transpose. Fine. Now your target is to find the C sigma and C sigma C transpose. This is my mean and this is my covariance matrix. Mu is the mean of the x, and mean of the x is given to you in the given statement is this is my mean and this is my sigma. I can substitute this value here. You will get as this is my covariance matrix. Now you can see this covariance of y, that is a y1 and y2. What is the covariance of y1 and y2? This is my y1, this is my y2, this is y1, this is y2. What is the covariance is 0. Therefore y1 and y2 are independent. So what is the y1 and y2 are independent is the right answer. So by all of 3 methods you will get the same result always. Look at this 5th component. Again, if I apply the first method, that is A sigma B transpose. So firstly you have to compare this y is Ax and y2 is Bx. Can you find the value of A? This is the component of the x2. So x1 is my 0, x2 is my 1, x3 is my 0. What is the component of the x1? Minus 2.5, x2 will be 1, x3 will be minus 1. Now for the independence you need to check about A sigma B transpose. I can substitute the value of A sigma and B transpose. So can you multiply them? So let me calculate it. If you multiply them, it's a minus 2.5 minus of 2, so minus 4.5. Next number is minus 5, minus plus 5 plus 5 plus 0, that is my 10, and the last number is my minus 2. So if you multiply them you will get as 10, which is my non-zero. Hence hence y1 and y2, that means these components are not independent. Fine. Or you can see they are dependent variable. This is the first method. Second method you can apply with the help of the covariance. I can open this covariance of x2 comma x2. Fine. And if you open them you will get as x2 and x2, x2 and x1, and x2 and here. So this is the x. What is the this is my sigma. Fine. In the given statement you can see this is my sigma. Now can you find the value of x2 and x2? This is the variance 5. What is the covariance of x2 and x1? This is my x2 and x1 minus x2 and x3. This is second row, third column, x2 and x3. So that will be 5 plus 5, which is 10. It is non-zero. You can see the same result you have obtained. They are not independent. Third method is we can apply the transformation. So you have to write this in terms of the matrix. So what is the A? What is the coefficient of x1? 0, x2, x3. Coefficient of x1, coefficient of x2, coefficient of x3. So this is my C. Now check what is the rank of this matrix. So clearly say the rank of this matrix is my 2, which is less than of the number of the column vector. That means C is my singular. Therefore, the y will be multivariate normal distribution having the dimension to whatever the rank of this matrix, that comes to be the dimension of this C sigma C transpose. Now, since we are talking about the independence nature, so we have to simply check about here, that is called as covariance matrix of y. So I can substitute this value. This is my C sigma. I can taken from this value. This is my sigma. Fine. And I can substitute this value here. Now can you multiply them? It's a 0 minus 1 1 0 minus 1. So let me multiply first row, second column, first row, first column. This value into this. So minus 0.25 minus of 2 minus 2.25. Second row, this value is a 5. This value is a 5 plus 5, 10 is a 0. Then its value will be the 0. This into this, it will be my minus 2. Fine. Now again you can multiply them. What will happen is a 3 cross 2 and it is, sorry, it's a 2 cross 3 and it is 3 cross, so it will be 2 cross 2. So can you multiply them? This number will be 5. This number will be 10. Because it is always a symmetric matrix. Remember, this is always a symmetric matrix. So it should be the 10. And the last number will be 2.5 into 2.25 plus 10 plus of 2. So you can multiply them. You will get as here. That is a 93.4. Now clearly say, what is that? This is the covariance between y1 and y2. So covariance between y1 and y2 is my non-zero because of the 10. Therefore, y1 and y2 are not independent. So what is my y1? x2 and this linear combination are my not independent. Okay, look at this another question. If x follows my multivariate normal distribution having the mean is my this, covariance matrix this, find the vector L such that x2 and x2 minus L complement x1 x3 are independent. So firstly, what is your target? Firstly, you have to check what is the dimension of the vector L. Fine. What is the x2? So clearly say this is my 3 cross 1. Fine. So once it's a 3 cross 1, what will be the size of this? It will be my, it's a 2 cross 1. So it should be, L should be my 3 cross 2. No. What should be the L is a 1 cross 2. X2 will be, X2 is a one dimension. Complete X. X means X1, X2 and X3. Fine. This X is my 3 cross 1. This X2 is my 1 cross 1. X1, X3. This is my 2 cross 1. So what should be the L? L must be 1 cross 2. So that, no, L should be 2 cross 1. L should be 2 cross 1. Therefore, L dash will be 1 cross 2. And when you multiply them, this will be my 1 cross 1. So I can return L should be 2 cross 1. So L1 comma L2. So can you find this value? It's L2. L complement. So what is the L complement is? L1, L2 and it is X1, X3. So if you multiply them, it is X2 minus L1, X1, L2, X3. So there is no need to write here. Fine. So what is the dimension of the L is? 2 cross 1. Now, so I hope you can like my video as well. So now, what is your target? Now you can read this statement. X2 and X2 minus L1 X1 minus L2 X3 are independent or not. Fine. So again, I will apply the three different method. The first method is I can compare this value of y is ax and y2 is b of x. What is my a? This is the x2. x1 is 0, x2 is my 1, x3 is my here. What is my b? x1, x2, x3. Fine. Now for the case of the independence, I need to calculate A sigma into B transpose. Fine. So it is given that because the vectors are already given to be independent, so that means this is given to you 0 here. I can substitute the value of the A. Okay, that I have applied the covariance matrix firstly. Anyhow, I will calculate A. A is my 0, 1, 0. What is the sigma? 1, 1, 1, 1, 3, 2, 1, 2, 2. And B will be minus L1, 1, minus L2. It is 0. Now you can multiply them. I can clear this screen here. Fine. So what is happening? If you multiply them, it will be 0, 1, 0. Then minus L1 plus L minus L2 minus L1 plus 3 minus 2L2, and the third row is minus L1 plus 2 minus 2L2 is my 0. Now you can multiply them. It will be minus L1 plus 3 minus 2L2 is my 0. I can find the value of the L1 from here, 3 minus 2L2. So therefore, what is your L? It is a column vector. L1, this is my L1, comma L2. This is the vector of my here. You can substitute any value of the L2. L2 can be any real number. You will get the corresponding value of L. Second method, I can apply the covariance. This is the second method. That means the covariance of y1 and y2 should be 0. This is my y1, this is y2. I can open this bracket. Covariance of x2 comma x2 minus L1 is outside. Covariance of x2 comma x1 minus L2. Covariance of x2 comma x3. It is 0. What is the value of the covariance x2 x2? That is the variance minus L1. Covariance of x2, second row, first column, that is my 1, minus, remember that this number you can also written like, it is my covariance matrix 2, 3. So you can read them. This is sigma, second row, third column, L2 of 2. Fine. So now can you find the value of the L1? Either you can find the value of L1 or you can find the value of L2. So I can find the value of L1, 3 minus 2L2. So you can substitute this value, you will get this required vector. You can choose any value of the L2. You may choose L2 is 1. You will get the answer is 1 over 1. 1 and 1. You may choose L2 is my 0. It will give as a 3, 0 and any. This is the transform. This is the y is equal to a. This is the first method. As I told you, if I compare a and b, as this is I already explained you. You can multiply them. You will get L1 is my here. Third method, that is a transformation method. I can write this is my y. I can write this into the matrix form. So x1, x2, x3, x1, x2, x3. Now this is my C. What is the rank of this matrix C? So clearly say the rank of this matrix C is my 2. Therefore, this value of y will be my multivariate normal distribution with the parameter 2 and C sigma, C mu and here. I can compute the covariance matrix C sigma of this. Now you can multiply them. So I think that is quite easy. You can multiply it by own. It will be first row, first column, 1, it will be minus L1 plus 1 minus L2. Similarly, you can multiply this, it will be minus L1 plus 3L minus 2L2, and then minus L1 plus 2 minus 2L2. Now you can multiply them again, it will be my 2 cross 2 matrix. It is given that these vectors y are my independent. So what does it independence means? The covariance between y1 and y2 should be 0. That means this number should be 0. Minus L1 of this is my 0. Again you have obtained the same value as we obtained in the previous two cases. Therefore the vector L is my. Okay, look at this another example. If X follows my multivariate normal distribution, capital X is my P partitions, X1 is of my P dimension, so definitely it is my of Q dimension because it's a P plus Q, such that sigma is the covariance matrix of this X. Take the transformation, find the vector B, matrix B, so that they are my uncorrelated. So what is given to you? It is given that y1 and y2 are uncorrelated, means they are, what is the meaning of the uncorrelated? Means they are independent. So once they are independent, it means the covariance between y1 and y2 is my 0. Or you can apply either the first method, second method, or the third method. So I can substitute the value of the y1 and y2. What is the y1 is? x1. So that is the covariance of x1. What is the y2? y2 is my this plus x2. Now I can open this property. It's a covariance sigma 1 x1, B is my outside, x1 plus covariance x1 x2. Now look at the properties. What is that? Covariance of x1 and x1, that is a variance, is a sigma 1 1. What is the covariance of x1 and x2? Sigma 1 2 is my 0. So can you find the matrix B from here? So you can see what is a B. You can easily find the value of B from here as this one. So therefore find the matrix B. So this is my matrix B. Hence your vectors are x1 into B. So I can substitute this value B and here. Or because we know why there is need of this, because you can see it just like say y is equal to mx plus c. So that means this is my dependent variable, this is my independent variable. So I have to write everything 2 on the 1. So I have to replace 1 2 with the help of 2 1. So therefore B will be my minus of this. So y2 will be my, and you know this is just like say regression equation. This is the line of this is the line called as the regression line of y2 on y1. So that's a dependent way. So I hope you can like and subscribe my YouTube channel as well. We will see the next lecture on the conditional distribution. Till then, you can like, comment and share this video with your friends. Best of luck students. Happy learning.